Saturn's rings look calm from a distance, a perfect silent halo around a golden planet, smooth bands of light catching the sun from a billion kilometers away, one of the most beautiful structures in the entire solar system. But if you actually fell into them, you would discover something terrifying. The rings are not solid. They are trillions of individual objects, ice fragments, rock, dust, moving at enormous speeds around a planet powerful enough to tear moons apart. And once you entered them, there would be no stable path out. What you're actually looking at. From Earth, Saturn's rings look like smooth, unbroken bands. They are not. Up close, the rings are a chaos of particles ranging in size from microscopic dust grains to chunks of ice as large as a house. Some are the size of sand, others are the size of mountains. Most are somewhere in between, irregular, tumbling, fractured fragments of material that never formed into a moon because Saturn's gravity wouldn't allow it. The rings are composed primarily of water ice, roughly 90 to 95%, mixed with rock and dust. That ice is old, ancient. Some of it may be the remnant of a moon or comet that strayed too close to Saturn hundreds of millions of years ago and was torn apart by tidal forces. Up close, they are chaos. The approach. You are still far away when the rings begin to change shape. From a distance, they appear as flat, uniform discs, the iconic image burned into every photograph, every textbook, every childhood poster. But as you close the distance, the geometry shifts. The rings separate into individual bands. The gaps between them, the Cassini division, the Encke gap, become visible as dark lines cutting through the ice. And then, closer still, the individual nature of the rings begins to reveal itself. The closer you get, the less the rings resemble rings at all. What you see now is not a solid structure, it is a moving field, trillions of particles orbiting Saturn at different speeds, jostling, colliding, fragmenting, and reforming in a system so dynamic that the ring structure we observe from Earth is the average behavior of countless individual events happening simultaneously. Saturn itself hangs in the background, enormous, its banded atmosphere of cream and amber stretching across your entire field of view, storms larger than Earth churning silently in the cloud layers thousands of kilometers below. The shadow of the rings falls across Saturn's face in a dark band. From inside the rings, you would see it from the other direction, Saturn's shadow sweeping across the ice around you, plunging sections of the ring field into darkness. Entering the rings. You cross the outer boundary of the rings. The first thing you notice is that they are mostly empty. That is what makes them deceptive. The rings span an enormous area, hundreds of thousands of kilometers across, but their average density is extraordinarily low. If you compressed all the material in Saturn's main rings into a single body, it would form a moon roughly 100 kilometers across. Spread across hundreds of thousands of kilometers, that material leaves the rings feeling surprisingly sparse. You are surrounded by particles, but most of them are far enough away that you can see between them. Sunlight filters through the ice at odd angles, scattering and refracting into unexpected colors, faint blues and pinks and golds that photographs rarely capture. The rings don't feel solid at all. They look like a field of floating crystals, extending in every direction to the horizon. But empty space does not mean safe, because the particles around you are not still. They are moving. Everything in the rings is moving, orbiting Saturn at speeds of around 15 to 20 kilometers per second. The particles closer to Saturn orbit faster. The particles farther out orbit slower. The differential speeds create a constant low-level churn, collisions, fragmentations, material slowly drifting inward or outward under the influence of gravitational resonances from Saturn's moons. You are inside a structure that is constantly in motion, and the motion is invisible to you until something crosses your path. And eventually, something does. Eventually, something hits you. Because eventually, something hits you. And in Saturn's rings, even tiny impacts become catastrophic. A fragment of ice the size of a pebble, traveling at 15 kilometers per second relative to your position, carries kinetic energy equivalent to an explosive charge. Not because of its mass, it has almost none, but because of its velocity. Kinetic energy scales with the square of speed. At these orbital velocities, a centimeter of ice hits harder than a bullet. The rings are not uniformly distributed. There are denser regions and emptier regions, the A ring and B ring. The main, brightest rings contain the highest concentrations of material. Moving through them is moving through a collision environment that any spacecraft engineer would describe as hostile. NASA's Cassini spacecraft, which spent 13 years orbiting Saturn and made multiple passes through the ring gaps, had to time those passages carefully, using the spacecraft's large antenna dish as a shield against ring particle impacts. Even with those precautions, the spacecraft regularly recorded impacts during ring plane crossings. Cassini was designed for this. You are not. A fragment the size of a pebble could hit with the energy of an explosion. And the rings contain objects far larger than pebbles. The scale of what surrounds you. Only now do you begin to understand the scale of what surrounds you. Saturn's ring system extends roughly 282,000 kilometers from the inner edge of the D ring to the outer edge of the F ring. That is approximately 73% of the distance from Earth to the Moon, a structure so wide that it would dwarf most distances we think of as vast. And yet, in most places, the rings are thinner than a skyscraper is tall. The main rings average between 10 and 100 meters thick. In March 2025, Saturn's rings appeared to vanish entirely when viewed from Earth. The planet tilted edge-on toward us, and a structure spanning hundreds of thousands of kilometers became nearly invisible because its thickness is so small relative to its width. A sheet of paper, viewed from its edge across a soccer field, would appear thicker. Inside that impossibly thin disk, you are surrounded by material in every horizontal direction, but above and below you, the full depth of the ring is measured in meters. Saturn begins to dominate. The longer you remain inside the rings, the more Saturn fills your view. It was always there, visible since your approach, but inside the rings, it begins to dominate in a way that is difficult to prepare for. The planet beneath you is so enormous, it no longer feels like a planet. It takes up an enormous fraction of your sky. Its cloud bands, jet streams of ammonia crystals moving at hundreds of kilometers per hour, are visible as distinct horizontal stripes. The hexagonal storm at Saturn's North Pole, a standing wave of cloud structure spanning 30,000 kilometers, rotates slowly above the pole like something that has no business existing in nature. The magnetic field extends millions of kilometers outward from the planet. You are deep inside it now. Charged particles from Saturn's radiation belts move along magnetic field lines, concentrating near the equatorial plane, exactly where the rings are. The radiation environment inside the rings is intense enough to damage electronics and accumulate biological dose rapidly. The deeper you travel through the rings, the larger Saturn becomes, and the more you realize that the rings are not the most dangerous thing here. What happens if you fall deeper? There is no stable orbit inside the main ring system for an object your size. The ring particles maintain their orbits through a complex balance of gravitational interactions with Saturn, with each other, with the shepherd moons that patrol the ring edges and prevent material from spreading. But a free-falling body moving through the rings on an uncontrolled trajectory will find that balance impossible to maintain. Saturn's gravity pulls harder the closer you get. The ring particles around you push and deflect. Your trajectory bends. At some point, the rings stop being the danger. Saturn itself becomes the problem. The outer atmosphere of Saturn begins as a diffuse haze of hydrogen and helium, thousands of kilometers above the visible cloud tops. There is no sharp boundary, no moment where space ends and atmosphere begins. The gas simply becomes gradually denser as you descend, until it is thick enough to create drag, and drag becomes deceleration, and deceleration becomes heat. There is no surface below you. Saturn has no solid surface. You might imagine, descending through the clouds, that there is something below, some rocky floor, some point of arrival. There is not. The atmosphere simply thickens. Hydrogen gas becomes liquid metallic hydrogen under the increasing pressure. The temperature rises. The pressure climbs past any level any material could survive. There is no surface waiting below you. Only deeper pressure, deeper heat, deeper darkness. What time is doing to the rings? Saturn's rings will not exist forever. Gravity is pulling the ice particles that make up the rings onto Saturn itself, raining down as a dusty ring rain. The rings only have about 100 million to 300 million years left. Recent research suggests that Saturn's rings may be relatively young, having formed about 400 million years ago, an astonishing fact considering Saturn itself is about 4.5 billion years old. The rings you see, the rings that have defined Saturn in every human imagination, every piece of art, every spacecraft image, are a temporary feature of the solar system. They appeared after complex life had already been evolving on Earth for hundreds of millions of years, and they will be gone before the Sun begins its final expansion. One day, Saturn's rings may vanish completely, and the solar system will look different forever. We happen to exist at the precise moment when they are visible. That is either remarkable luck or simply what it means to be alive at any particular moment in a universe that is always changing. What you would leave behind. Right now, Saturn's rings remain one of the most beautiful structures in the solar system. But hidden inside that beauty is a place of violent motion, constant collisions, and gravity powerful enough to reshape entire worlds. The serenity you see from Earth is real, and it is also an illusion. Because beauty in space does not mean safety, the rings are quiet at the scale of the solar system. At human scale, they are a collision environment moving at orbital velocities, surrounding a planet whose gravity has been tearing things apart for billions of years. And if you ever fell into them, the solar system would stop feeling peaceful very quickly. Do you think humanity will ever explore Saturn's rings up close? Let me know what you think in the comments. There are still planets, forces, and mysteries in the solar system that we barely understand, and the deeper we look, the stranger everything becomes. Subscribe if you want to keep exploring.